as you love.
Uh,
Wait, why the browser?
to each
Yeah, to
Oh,
see to monitor the chat and
to
then the
monitor the
bots.
fact that nobody will watch us.
Okay, now you can give the reasons, Nathan.
okay. So I'll be right in the chat. So
We wait all of this to you to
Yeah, we
say
wait
it,
all of this
and
for
then you
him to
say,
write
"Okay,
in
I'm
the
gonna
chat.
put it in the chat."
no, no, it's because I have to illustrate and I have to write somewhere, right?
Oh, okay, that's
Dude,
fine.
So the
you've
place I
gotta be
have is the
joking
chat.
me. You've gotta be joking me that we have 17 followers on Twitch.
Yeah, that doesn't make sense, right?
How? No, man. These are bots. Like, there's no way. Who would follow this
We have
guy?
56 subscribers as well, so I don't know if all of those are bots.
That's weird. Anyway,
Yeah. Okay, so Nathan is typing down why is the reason that we cannot make the ADTs recursive the same way
I
that we
Okay,
think I
made
have an
the.
so
idea.
you agree that will be a recursive type, right?
Yeah.
But we are referring to net list on the right when that's the very same fucking thing we are defining, right?
Yeah.
So, well, no way it's happening. So, in type theory stuff, they call it a mu type, like the Greek letter
Yeah,
that
yeah.
I
The
don't know how to
letter, right?
pronounce. So, a way they do that is by doing the following. And that part looks like uh, the fixed point stuff.
Oh, really?
So, yeah, that part it is. So they do like that. Let me just grab the letter.
Okay, so aside from that, we can also debug why do this thing cannot be a map empty, otherwise it doesn't work. And I don't know exactly what was the epiphany that I had in the middle of, I don't know, 2 a.m. After Mageta left.
Let me see. So the case was that it was filling the methods with an empty thing right
Yeah, so the,
inside.
the solution to that problem that we were tackling before you left was, oh, this was map empty, this thing. And then I
Oh
said,
man,
what about if
what,
I have the
dude?
environment there instead of using
Yeah,
empty? And
but
then
dude,
it
like
worked.
it will. Yeah, it makes sense because like what you're adding there are the lambdas representing the. I don't know how it wasn't failing. Don't ask me this, but I would think it was. It couldn't generate the keys. It's not a do not. Man, I have no idea. I think I'm wrong by saying this, but because it was, we're basically generating variables, right?
Yeah.
You're not passing the environment to which those variables represent, then I think it should be a failure. But because remember, those variables are bound outside, right? You should bound them outside from the environment. But
No, wait,
why?
wait, wait. There's a separation there.
Hmm.
Because these variables that we are creating here, why it makes sense to this to be to like it can be an empty map because these variables they don't exist, right? We are creating them because of a limitation, right? So we are creating them and they have random names that we're using numbers in this case. Like in the environment that for the closure, that doesn't matter. Like this should be
Yes,
empty.
yes,
Like it should be empty.
yes, yes.
But that's the thing. My guess, and we can check that using the bang, using unsafe from IO, is that the type variables are inside this guy, and that's why it was not working.
The type variables are inside that guy, but the type variables shouldn't matter, right? Because
What is the problem of that?
The problem is that, well, let's undo this. Let's all
wait,
undo this.
dude, the type variables, but this is the evaluator, which is just has an empty environment. Like it doesn't. Well, it has the prelude, right?
No, it has a prelude, that's the thing.
The thing is, it doesn't matter what there is there because the things we are going to use inside the lambdas, they are being like bind by the lambdas. So if there is already something there, we will overwrite it, right? If there is the same name.
Yes,
So
I totally agree with Nata in this case. But that's the thing. We can reproduce the problem that we had before using this, right?
Mm-hmm.
Just that, and that will give us the same problem that we had before, Mageta. So let's demonstrate. Let's demonstrate that it doesn't work with using map empty.
Yeah, it works, right? It just doesn't show the
No, no, no.
just
It
doesn't create
doesn't.
members with cases with like parameters, right?
Wait, it
App.
doesn't show what?
You will see. Like it makes the
Uh,
methods, the cases, the function cases, but it makes them empty, like without any variable
yeah.
inside.
adt.swv. Yeah, here.
Like this.
Yeah. So
So
wait,
although
but
we
it is
defined,
working.
no, it was wait, what? What? But then how does the from list, which is the environment, I guess?
Yeah, this is the environment of the. Well, this is in the environment of the evaluator without the prelude. I am doing a difference with the set of using the prelude, the map.
What? Dude, this is how?
But it is working. You
You're
see?
not type check.
No,
Oh, you were. You're not. Okay. On the type checker, it does, right? Show the thing. Can you show the environment of the type checker?
yeah.
What are those like either left, left? Like what is that?
Is the
Those are
either?
the ADTs. These are the ADTs that I created, right? And we
Wait,
have two
what
names.
kind of environment is that?
This is the evaluator environment.
Oh, okay, so those are the constructors, right?
Yes.
Yes. This is the qualified names and the unqualified
Yeah, the
names.
qualified and the unqualified. So the type of that is this.
Yeah, the types are fine. The problem is on the evaluation. Can you put back the env?
No, no, no. But if it works, then I don't know
No,
what
no.
we were
Just
drugged
see the
before.
difference. Just see the difference.
From the example you are running.
Yes.
Put it to compile first.
Okay.
Okay, so this is the example that we are running there.
Okay.
Gnome is fancy, man.
Yeah, I would say that is probably something weird with the printing that could.
We tested that. That was the problem.
It
Okay,
worked.
put the V again. What?
Still
So,
empty.
dude, didn't fix anything.
No, but that's the thing. I am like again. It is possible that both you and me we were crazy before. That's totally a possibility, right? And it
And
was a
also, it could be multiple changes. Like you changed that and something else,
no, no, no.
right?
I didn't change
Yeah.
anything else aside from this.
Yeah, but I
Oh.
think that should be map empty, man. It doesn't make sense to pass the environment.
Exactly. No, I agree. It
These
doesn't make
are
sense. I
empty
just tried just
functions.
because to see what happens,
Hmm.
and it
And
worked.
maybe something else that could even simplify the code. Like we are doing the closure as the outer one, right?
Yes.
But we could just like do all abstractions, including the outer one, and just like throw an eval before all that. Then
That
we
would
don't
fix the
need.
printing. That would fix the printing.
Huh?
That would fix this mess.
What do you? No. Wait. Lemos. Uh, it would not, because the value would be exactly the same.
No,
Because we would.
it would fix because the abstraction eventually would have an it would do this, right? The abstraction eventually.
Go to the function that we were.
This.
So this gets us a value, right?
Oh, okay, yeah, you're right. You're right. Okay, so you're right.
But the thing is, maybe the code maybe makes the code better. For example, you will not have the inexhaustive pattern matching there because you don't have to do head and tail. So that will be better.
This is stupid.
What do you
Uh,
mean?
What's the problem that can happen there? I don't see none. Just
we
put
know
that
that.
flag on your thing and it disappears. The problem doesn't
Yeah,
open.
no, that in theory it doesn't happen, but well, it's too bad code, right? It's like dynamic, like you know some things like will work, but well, you don't guarantee,
I
right?
know that some will not work as well.
Huh?
Just don't
Man,
know when.
that take of Magetta. It's totally like
We should do
Magetta
a
style
Nekoma shorts
demonstration.
then.
Kung Fu.
We could do a Nekoma shorts or something like that.
Yeah, but let me show the type thing before I forget stuff.
Yeah,
Uh,
okay.
so I have in the chat there, like you can copy and paste to the editor if you want. So that's the way they do. They
Oh,
call this
Emacs
thing
has
as
this thing. Cool.
What do you mean?
What?
Yeah, I was not expecting this char to like be a char properly, you know.
Oh, dude, Emacs
That
has
doesn't
emojis.
depend on Emacs, right?
Dude,
No, of
Emacs
course it
has
does.
emojis.
Uh,
I put an emoji there.
No, emojis also work, but
Yes.
anyway, go.
So yeah, so they do that thing. They call that like a mu type in theory stuff, and you have this binding where you can like use it inside, right? It's kind of like the thing with the fixed point in the sense of when you want to transform a function in a recursive one, what you do is you receive yourself explicitly in an outer lambda, right?
Oh, you mean the Z combinator, right?
No, it's not specific to the z one, and it's not the fixed point itself. It's the function that the fix receives. For
Oh, okay,
example,
okay.
you got it,
Yeah.
Magenta?
Wait, sorry, I wasn't paying attention.
Yeah. So let's suppose you have like a recursive function, right?
Mm-hmm.
Uh, so then we want to transform. Well, it is a recursive function, but it doesn't like work, right? Uh, we want to transform in a recursive function. So the way we do is we receive itself in an explicit way in a lambda. Like Lemus can type it out like to demonstrate. But if you have something like Fibonacci is equal to tarara, and you use Fibonacci inside the tarara, it doesn't work,
Mm-hmm.
right? And it
Mhm.
doesn't work because it's out of scope, right?
Yeah.
Yeah.
So yeah, so the way you do is you receive another parameter, right? You receive something like f before n.
And then you use
And
F in
Oh,
here.
okay. Mm-hmm.
yes,
And then you use this, and then the best part is that you can do that, and then it works.
yes, then
Yeah.
you get this function that you made and you pass to fix,
Yes.
and that will give you the proper recursive function.
Yes.
So it is like in the same way of, oh, okay, let's add a lambda here. It's not really a lambda, it's a mu type shit. But, and we will receive what we are using recursively, right?
Yeah.
So that's what you are looking at the mu type there.
Okay. I see.
So there are like two approaches to model this kind of stuff. One is called equi-recursive types, and the other is called iso-recursive types. The way they differ is something regarding, how can I say, like how they define equality of stuff, right? So you agree that if I'm doing like a list, like a nested list, if I would describe it, a tree of it would be something like, oh, inside the X there, it's the type itself, and inside that type itself, it would have another X that would be itself, like, would be like a tree recursing, right? Like,
Yeah.
I would have to like represent that type and it would suck, but uh, how can I say? So, okay, think of the following. You are seeing the mu type there, right?
Mhm.
So take this whole thing and copy it.
Take this whole thing.
The whole right side of the equal sign. Copy that.
Mhm.
Now you like put there, right? And then you do the following. Delete the mu part, delete the binder. Yeah. Now delete the X and Control V in that place. Yes. So that would be an expanding or unfolding, right?
Yes.
So yeah, the relation between the previous one and the unfolded version is how the way you model differs. The equi-recursive say they are equal. So it's up to the type system doing the equality to do some algorithm that like matches this both as the same type, right? The ISO
Wait. You're, which ones are being compared that you're saying that will be the same in this strategy?
the first one that you have there, like line 3 up,
And the
and
one
the
up?
line 1 up. Yeah.
Oh, okay.
They are like different types, right?
Yeah.
One is a mu type, and the other is a sum type with a mu type inside.
Yes.
So yeah, so they are different.
Hmm.
The way you do in equi-recursive type is on the equality function for the types, he will do some kind of algorithm that like will just match those two as equal. In
Okay.
the meanwhile, the iso-recursive types, they are, well, isomorphic. So they are not equal per se. They like if you try to do that on the equality function, it would return as false. But what they do is they introduce some operators to explicitly manipulate the folding and the unfolding of types. So if you want to transform the first version into the second, you call an operator called unfold. And if you want to do the opposite, you call an operator called fold. So that's how you transform one type in the other until they match, right?
Wait, is this the second strategy?
Yeah, that's the ISO recursive
Okay,
type.
so one uses fold and unfold, and the other one does a very like fancy and targeted
And
equality.
yeah, implicit one, yeah. And the fold and unfold is very explicit, right? Like you
Yeah.
type the operators out. Uh,
Okay.
so the so the thing is, the equi-recursive type is much easier to, like, more natural to understand and to prove some stuff about and to model. Some specific interactions are really complicated, like with some more like complicated features. But the iso-recursive type is much more straightforward to implement, like a lot more straightforward to implement, because you don't have to do the fancy stuff on comparison, right?
Mhm.
Uh, at the same way, like it's more explicit, right? So you need explicitly like have folds and unfolds, and that can kind of suck for the user, right? Uh, but the thing is, it doesn't need to be explicit to the user because it coincides that if we do something like every time I put a constructor, I add I guess it's like an unfold or is it a fold? I forgot which one. But you do the thing like the following. Every time you do a constructor, you put one of those. And every time you match, you put the other one. So they cancel out. So that way everything like just works like magic. So the user doesn't see all the folds and unfolds. Oh, come Haskell, they do that, and that's how it works. The constructor introduces one, the match like puts the other, and then they cancel out.
Okay, okay.
Uh,
So that sounds a little bit over the top for today because I think, well, I don't know about Mageta, but I think I need to read some reference material to get that more comfortable with. So I don't know about doing recursive edits today.
I repeat it. I don't know how to implement that, so
No, no, no.
it's not.
Let's do the following. Do another thing, and then we go back to this once we did the proof of concept with this.
Okay.
Yeah,
So let's do pattern matching because this thing was fixed by me and Mageta being drugged, and then it's just working.
Drugged.
Let me just double check this
I was
information.
afraid you're gonna stay like until 5 a.m.
No,
and
no, no, no,
you're
no,
going
no,
to die.
no, 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 not happening. So let's do just this. Yeah, and it works. Okay. Well, if you want,
Can you test
Nathan.
with the type checking
Yeah,
enabled?
this is with the type
Okay.
checking.
Yeah, yeah. Okay.
Well, Nathan, if you want to also take a look on this, because I think you said that this is weird for you, so maybe you have something to say. So do
it's
you see
weird.
this v closure here?
Uh-huh.
And you ask about this function here in Discord, right?
Yeah. It's true.
Yes. So in your mind, we should just we don't need to use a special function for printing, right? That's what you said?
Yeah.
Okay, so let's test that out. So I will actually I don't need to comment this. I'm just gonna pick instead of doing
What?
that.
Wait. What are you testing exactly, Lemon?
Well, we know that whatever is this is of closure, right? So the thing that I got with Magetta is that if you assume that this is a closure and then just do fun here, right? So because this is a closure, and then you don't add the special printing, what happened last time was that we couldn't print.
Well, you mean you couldn't print how you wanted, right?
Now we couldn't print the constructor with the value,
Okay.
and now we can. So Magetta,
Mm.
you see there?
Yeah, dude. Just one thing. Please remove the column, man.
That
That's
column.
disturbing me.
The column there, you mean? Okay.
That's disturbing me.
Okay. Okay,
Thank
so
you.
something happened. Something we fixed in the code later, apparently. It fixed the printing as well. Because I am saving stuff, I am rebuilding every time. And I remember with you that when we did the first time, it didn't work correctly. Right? But now it is. You see? So I don't know what we did later to fix that. Maybe we've added something to the generate algebraic or the add functions to env, but
It
now it is
was
working.
fairy powder that made it work.
Yeah, it's some magic, I guess. Okay, pattern matching then.
I was
So,
literally saying it was arcane. Arcane behavior.
uh, 1 second. Okay, so Nathan, you said already that pattern matching is very easy. Is that right?
I don't remember saying that, Lamos.
I remember you saying that, and I think I
Well,
am more trustworthy than you in this case.
well, I agree with that, but again, I don't remember, right? What can I say? I cannot confirm that you are right because, as I said,
My first guess would be to add a new node to the expression ADT. Am I correct?
trust your guts.
Trust your guts. Okay, so E pattern. So Magetta, what do we need
No,
in
no,
the
wait. Be more specific with that, Lemos, because maybe we need the name like only pattern in the future.
wait, what do you mean the name only pattern?
Choose a name that like reminds you of pattern matching, not just the pattern part,
Okay.
because we will use the pattern part as something else in the future.
Okay. So pattern matching, E pattern matching. Okay. So what do we need in the E pattern matching node, people? My first understanding that we need an expression,
Uh, we need a match, I think.
and then we need a list.
Let's think. First question? Do we have the metadata to match things? What do we intend to do our pattern matching on?
Well, I understood like I don't know. Match. Oops. Oh, match, and then V. We don't want the off, so match V. And then you're gonna do I don't know left
Another
something.
list I was thinking.
The list are the
This is
branches. These are the branches.
no man. Wait, this is getting inconsistent. Wait a second.
Okay.
What do you mean by is getting? You're
What are
not
you
serious,
talking about,
man.
Nata? What are you talking about?
You are not serious at all, dude. It is inconsistent from the get-go, man.
No,
Shut
that's
up.
not
Nata.
true.
Shut up. That's not true.
It is true,
No,
dude.
That's
that's
false.
not true, Nathan.
We
You
can
know it
take a
isn't.
look. No, no, it is. We can take at first features and we can see already that they are not as expressions.
They are
No, not
fake
all
ones.
of them.
That makes me happy.
Wait, what makes you happy?
Makes me happy.
What exactly?
Well, these expressions they make me happy. Don't try to devaluate my happiness.
No, I was trying to understand what makes you happy, my gift.
Oh, this syntax, the whole syntax we came
Oh,
up with, it's beautiful.
okay.
I love
we
how he
can
didn't
discuss about
complain
the
about
syntax
anything.
later. The only thing that I understand is that we're gonna have some match here
Like
and then
this.
space, right?
Perfect, man. Perfect.
Oh,
And then I don't know, we do something with that. And I think that these lists are the list of branches. Is that correct?
You
Does that make
think
sense?
I well, I let me see. Expression. Okay, you want to propose a list so we can change the syntax like this, and then it will be exactly the ST.
No, that's actually gonna have to be a list of tuples, I guess.
that's actually good, Magita. That's actually good, man.
Hey, Nathan agrees, man. Like this.
Because easily, wait,
Why? I don't know.
no, now it's not anymore. Why did you put a list between the branches if it's a rest?
Wait,
Why did you
can you
put a
see that?
list between the branches? A
Because
list?
it is a list of expressions.
No, you have the branches, right, after the V.
Yeah.
Yeah.
So that doesn't need to be into explicit list because it is a rest, right?
It is a
Oh, I
rest. I
see
don't
what
know
you
what you
mean.
mean. I have no idea.
Yeah, I see what you mean. So these, right? Oh wait. So let me roll back.
Lemus, like if all the rest of the things of the list are the same type of stuff, right? You
Hmm.
don't need to be explicit about being a list. You just like
Mhm.
get as a quote unquote rest.
What do you mean by quote unquote rest? That's all what I don't understand.
For example, let's suppose we have a plus operation here, right? Like after the plus, we have a list, right?
Yeah.
So we don't need to put like the 1, 2, 3 inside the list, okay? Let's suppose we have the plus function takes a continuation, right? So it takes something like this. It's plus f1, 2, 3, something like this, right? The f is a function to be executed after the computation, okay?
Hmm.
So the following syntax makes sense. Why? Because you have plus, you have the f, and all the rest is like uniform. They are the same kind of stuff, right? So you have plus, f, and rest. But if you want to do the f by last, then you would have to do the following.
Yeah. So in my mind, while you type is it will
You
go like
would
this.
to have something like that. Because if you do the opposite, you have a terrible problem. You cannot just get rest and the list be infinite, right? Like you would have to know how many you expect and then to get the F afterwards. Of course, like in practice, you could get the rest of the list and take the last one as a function, but still, it's not how
I'm
they.
still very confused in what that implies in the e pattern matching node. Can you be more explicit?
Nothing. That's regarding the style that Lisp like puts the parentheses in.
Oh, that's what you're talking about.
Oh wait, what is the discussion now? I wasn't paying attention.
It's
No, because
regarding
I
how
was
the.
understanding that Nathan was saying something that implies a different things in the node, but what he's saying is totally just like being consistent in the Lisp way, I guess.
Yeah, yeah.
Okay.
Interesting thing. Interesting thing. What is a type there, Lewis?
This.
Mm,
Mm.
that's not a type, right? That's an application of a case
Wait,
of a
isn't that a
given.
value that we made, like the V algebraic
That's
stuff?
very interesting.
Yeah, because that is actually a function, right? We can understand it like this, like the left. Like
Oh,
the
I
way
see
you
what
put
you
it there.
mean. I see what you
Syntax.
mean. But that's a problem, right?
No, I'm not saying. I don't think it should be a function though.
Yeah,
It doesn't make sense.
that's my understanding. We want to extract this value out. But in my memory, that's the reason why we made the V algebraic has this list here.
Why?
Because we want to be able to access the values that
Oh yeah.
we have in pattern matching.
Mhm.
So the first thing to take a look, like the first thing is, what is right, like type or value? Well, neither of them, I guess.
Neither of them.
Yeah. The,
Then I
the
am
first
very
thing,
confused.
yeah, the first thing that we need to take a look is on value.
Okay.
Do we have variables node in value?
Variables, no.
So that's already a problem, right?
Oh, because we don't have the ability to give a name to the value.
Yeah, like, uh, I'm not sure what you mean by that, but I mean, if that's a value, right, and it is carrying a value inside that is called just A, what is that value there? Like, is it the value string? Well, not really, right? So you don't
Wait,
have a value variable.
wait. I don't get your example of value string. Can you repeat?
Okay, so go back there. Uh, so there are two major problems there with you putting value there, right?
Okay, go on.
So the first thing is you are not evaluating anything. That's what the parser will return, right? So how does the parser returns a value? Like
Okay,
a
so
value
okay,
is
so
supposed
definitely
to,
it's not value here. Definitely.
yeah. So
Yeah.
that already like result, res, rel, well, it's not possible, right?
Yeah.
So type. What is the problem with type? So the types that you are describing there, what it is?
I think I have an idea, but go on.
Okay, but my idea when I did the type was to put
Type for
algebraic
you.
when I did the type down here. That was my idea before. But we need something to carry this, not only the type, but this stuff as well, like this
Why not
name.
a type the and the list of variables?
Okay, so you're proposing a type. Well, we can do a triplet in this case. So a type and an e variable, a list of e variable,
Oh, I wasn't thinking of a. Okay, you're thinking of a triplet. Okay, that's fine.
like that.
Yeah, something like this. And by the way, we could make it the expression e program, so we don't have to e program on the expression instead of
Oh,
expression.
that's true. That's true.
Oh no, we cannot. Wait, that's saying bullshit because it is the type of an e program is expression. So never mind.
Oh, okay, okay, okay. So it has to
Yeah,
be expression anyway.
yeah, that's fine.
Okay, so
So
your idea is to have this being the left, this being the I don't know how many whatever things we
yeah,
have, and this
I'm just
being the
thinking.
branch.
So the first question is variables, right? Like you want variables,
Yeah.
but well, of course you have to type as expressions because,
Yes.
well, that's the
Mhm.
type of variables. Uh, but the thing is, if you are using only labels there, always, why do you need expression if it can only be one type of expression?
Okay,
Yeah.
so label instead of that. That's what you're saying.
Yeah,
Uh,
yes,
like for
right.
example, think of a pattern matching of a left that has two things, and you want to match one left that is like integer one, let's say. How do you handle this?
Integer one.
Like for example,
Oh,
if
okay,
you
okay,
do
yeah, yeah. So, yeah, I
Oh, so you're
should
talking
have.
about
Oh,
doing like
like
that, I guess.
yeah, something like this. Like okay, I want to pattern match if it has one, the first integer being one. You see?
yeah, so I have to talk about something first. The first thing is, I think that on the first like iteration, we shouldn't aim to do the same thing that like OCaml has because it's a lot more complex. So I do think we should aim on something like, okay, I can match a sum type, so not any type, just a sum type, right?
Okay.
And then I can lay down the constructors and the thing that they bind, and that's it. I don't have recursive patterns. I don't have different patterns than just normal variables to bind. So the thing that Magenta is saying is he wants a pattern that includes the literal ones.
Yes, that's what he's
So
saying.
yeah, so that's more complex, and it doesn't work just put the thing there as expression because you cannot put arbitrary expressions as patterns. For example, A function is not a pattern, right?
Oh
A
yeah, that
match is
makes
not a
that.
pattern.
Yeah. So yeah,
Yeah, that I agree. But
that
for
that
example, a
makes sense.
literal, we can resume things to a literal, right? Depending on the value, because then I would think, okay, we have one, which is an illiteral literal.
What the fuck is the able there?
What?
What
What the
can we
fuck?
pattern? What can we pattern? Go on, Magita.
No, no, they are patterns.
Patternable.
Yeah. Go Mageta. What can we
Let's
pattern match?
So, for
We
example,
can
the
pattern match
literal.
functions, right?
No, functions I don't think makes sense.
Yeah.
Or maybe if we
Literals?
invent something very crazy, but okay, pattern match a function, that's actually the name of it. I don't know, man.
Oh,
That's
man, that would imply on you being able to do equality of functions, and I think we talked about already that like
yeah.
that's a problem.
Yeah, that's a problem.
But we can kind of do equality of functions, right? We just
Yeah, you can kind of
AST
do.
compare the AST if it's the same. But
Yeah,
even then, it's not really equal.
and that would only work for interpreting because compiling you would have a different representation, right?
Oh, you compare the bytes.
Well, then you have to save a lot of stuff.
That's stupid, man. So, what was I going to say?
What other things can we pattern match aside from literals? That's the question.
Lemos,
Yeah, that's what I
again,
say. Just literals.
No, just literals.
Yes, because what can you go to the value AST, the value bullshit? List as well, right? Yeah, I forgot the lists are not literals. So everything that is in there apart from the closure. Let's see.
And ignore
Native
this
function.
vunit stuff that is randomly here.
Let's ignore the record for
unit
now.
is a pattern.
No, it is a
Even
pattern,
simpler
but it is
than.
a literal, so it shouldn't be here separately.
Oh, okay.
Yeah, okay. So let's ignore the v record, the closure, and the native function. But I think all the rest we can pattern match.
Well, wait, why can't we pattern match v record?
No, wait. I think we can. I just don't want to think of this now.
Okay, that makes sense.
Oh, so yeah, you guys are making a lot harder than it should. Because again, it's not as simple. Why is not? Why is not just add like patterns there and then it can be a pattern and we do the algorithm to matching? The problem is you doing that, you not only like add the complexity of having like pattern instead of label, but the algorithm for you to do the completeness is a lot harder.
Yeah, I
Because
agree that
when
the
you are
function
binding with labels, well, it will always bind.
It will always bind, yeah.
But if you have something like literal, then it not only influences the branch that you are doing, but the next one regarding completeness and shit. Like, if you want to do that now, it's okay, but it's a lot harder.
Yeah, I think for the time being, for the first iteration, I think we should aim for the label, Magita.
okay.
And then later on the line, we can upgrade it to have like literals and lists and stuff like that. Okay, so let's continue our discussion here. So it is a list of triplets in which we have a type, which is the left. Then we have the list of labels. So actually this case is done. And then we have an expression, which is what comes after, right? Does that make sense?
Kinda. Again, what do you want to do with the type?
Well, what I want to do with the type is just matching, like, oh, left, and then this is a type, and so on and so forth.
So can you copy and paste there, like above the match there? What is the V algebraic that you want
Sure.
to return on the parser?
Okay, so let's actually go here. So let's make a function called ABC.
No, wait. What I'm asking is, on our Haskell types, we have the V algebraic case that you are saying is what will be there, right? The type.
No, I'm
So,
not saying that anymore because, as you said, the parser cannot get values, right? It can only get expressions or types.
No, but
no,
it
no,
can
no,
get
the
the
type.
expression, but it can evaluate the expression to a value.
What I'm talking is the following. You put a type there because you said, oh, that should represent the left and the right and such, right? Then
Mhm.
I asked you, like before, not right now, uh, what type you meant to be there, and you said, oh, the algebraic one, right?
Yeah.
Because it has the information should. So what I was asking you is get the representation of what the type T algebraic is and paste there, like on your match example, so we can take a look if it makes sense.
Okay, so the algebraic is this.
It's literally the most fake Lisp that we could come up with.
What do you mean?
Dude, this is not Lisp at all, man.
No, but I
Yeah,
never
no,
said it was supposed to be Lisp. I never said that.
You know what? But dude, it's horrible because it looks like it is, but it is not.
by the way, like I would say that main arguments for doing that is either oh, it's easy to parse, or it's
Yeah,
just beautiful. And well, we are not like leveraging the part of being easy to parse.
I thought you were gonna say it's not beautiful.
No, it is easy to parse. Not being S expressions would be
No, no, no.
way.
Again, I'm saying we are not leveraging the fact that it's easy to parse.
Oh, we are not
We are not.
mentioning, you say.
Huh?
We are not mentioning, you say.
We are
I
not
think we are,
leveraging.
dude. I think
What do you mean
the
by not
heavy.
leveraging, dude?
Yes, dude. I think we are. Like,
No,
Not at
it would be
all. For
100%,
example.
like 1,000% harder without being S expressions.
No, no,
I mean,
dude.
there are. I agree that there's some things we're not. For example, everything that starts with a variable we could handle as an application like Lisp, normal Lisp. But then we have other things to improve. Like, but I don't think that's like a leverage.
Oh, dude. You want to do the ultimate leverage? That's the following. You literally do a parser for S expressions. Like, it's either this label here, symbol stuff, or it is like a list, right? And that's it. That's your whole parser. You return something
Yeah,
like that, and you can call a parse tree. And from that, you match that, and then like from that, you can like already like you can know like what kind of expression is, and by that you can
I
like
think it
either
would result in the
translate.
same complexity we have right now because we wouldn't have to convert to VST.
Dude, it is not. Why
It
it's
is, man.
not? Because the parser is much more complicated than
That
doing
is
Dude,
matches.
that is the S
dude,
expression parser.
dude.
Literally, quite literally.
I don't
So
think the
how would
parts is that much
how would
complicated.
be the transformation slash validation, Maketa? It's easy. You get a list, you maybe check its length, you check if some elements has some specific name that you want. That's very simple. That's just
Yeah, that's
pattern
what we
matching.
did on the Como Lisp thing.
Well,
The
so you see
parser,
how that's easy? And the
yeah,
parser
I
is
know.
very
The
easy.
parser was just like three things. Like we just parsed three things. But I don't think that with the fact that we moved things to the parser made our parser more complicated. I mean, there are
What do you
some things that
mean?
I think are unreadable.
No, no, what do you mean? You literally said it was three things and then compare that with ours. Like it's huge.
Oh yes, but
Yeah, but
And that's not more
I
complicated?
still don't understand how you guys are saying it would be three things. What which three things it would be?
what? Think
It's
of this.
actually true, right? But
Everything is a symbol. Like everything that is like a text, it is a symbol. Everything that is not a text, it is literal. Like it could like a string, integer, whatever. If something is in, and everything else is a list, and then you have okay. How do you differentiate? How do you do an application? Well, an application is just a list where the first thing is a symbol.
No, but isn't that because almost everything in Lisps are composed out of lists and symbols?
Yes.
I don't think that's in the definition of S expressions. That's a different definition.
Definition of S expressions is
That you don't
I don't know the
you
definition
have
of S
delimiters
expressions.
instead of prior of precedence, as far as I can tell.
Let's see. S expressions
Maybe I'm
definition.
wrong, but my understanding is that the things that you said, those are Lisp
I know it's
properties,
like to
not S
basically just
expressions
represent
properties.
the AST as it is. Like here, symbolic expression abbreviated as sexpr or sexp is an expression in a like-named notation for a netted list, tree-structured data. S expressions were invented by the popularized programming language Lisp, which uses them in source code as well as in data. So that's
Oh,
it.
they were literally invented by this. Holy shit.
Yeah, I know that the first
That's
version of X expressions was written. I know that the first version of Lisp was written in the AST, and that was Lisp itself. So
But yeah, dude, you cannot say your thing is leveraging. Oh, it's easy to parse because it's less expressions. Like, no, that's bullshit.
at least we removed ambiguity.
Oh, yeah, that's the best part.
Yeah, I guess we are not leveraging 100%. You guys, it is in the definition that you have the Wikipedia is calling atoms, which I guess in this part called symbols.
Yes.
So yeah, so we could
Atomic
leverage a
symbols.
little bit better.
Oh man, they make another term, atomic symbols.
Um, okay, so the discussion was
I
that this, as far as I can tell, this text is the left.
Just one comment. I saw a dude commenting something that I thought was really beautiful. He was mentioning that he saw his colleagues at university making just making a toy language, and they were writing Lisp back in the 90s. And then I was thinking, man, I did that in C and it was really hard. And then he saw his friends like playing around with Lisp, and he saw them doing the thing. And what was fun is that they literally just parsed the code and executed in Lisp because it was like Lisp itself, you know.
Yeah,
So
yeah,
they
yeah, yeah. That's
literally,
a very famous exercise. I think it's in the
yeah,
book.
yeah. So like you can just make a reader, just change a little bit, and that's it.
Yeah. So, are we okay
Okay, with what?
with this representation for a pattern matching?
Oh, I
Because
don't know if
Nathan
I'm
wanted to
okay with.
check the T algebraic data type.
yeah. So take a look. So you have an expression, the first one, right? It's the one that we are matching.
Yeah,
And you agree that on the type check, we are going to, well, type check that expression, right? It's
yeah,
the least we can do.
yeah.
So getting that, it needs to be a sum type, right? For our purpose here.
Well,
Like
this
for
you're talking about that we're gonna type check this guy, and you're gonna see if it's a T algebraic with a list of text and empty.
yeah, like
Yeah.
that's our sum type, right?
Yes.
So it needs to be because, well, that's how we are doing type checking for today at least.
Yeah.
If not, then you shouldn't be matching, right? It's an error.
Yeah.
So okay, we type check that, we get the information that is a sum type, and he brought us that information of uh, text. Wait. Oh, okay, because you are highlighting the outer list. Can you like move up? Okay. So okay, we have that list of texts, like well, of a tuple that the left side is text, like saying the constructor and the types, saying what it takes, the length and such, right?
Yeah.
So yeah, doesn't that give us all the information that we need to know about what needs to appear on like the branches regarding the constructor names
Yeah.
and like the binds?
Yeah. In my point of view, we're gonna pick the left that we have that the parser provided us, and we're gonna compare with this to see if it exists in the context.
Now
And
my question is, let's suppose you are like parsing to the constructors, right? And I will not even ask how you are going to get the type from that, or how you are going to get the right type for that. But once you do, right,
that's a very good question.
how do you know, like, what is the constructor of that specific branch? Because the T algebraic doesn't say, like, okay, what is this branch? No, it lists all the branches.
Wait, your question is how are we gonna know?
Yeah, so let's say you parse Pilitro, right? And that gets you the T algebraic type, the one that it should be indeed, right?
Hmm.
So how do you know, like when you get this and you want to type check stuff, how do you know that that was the Pilitro? because the algebraic doesn't represent that in any way. Like it has all the cases, all the
Wait,
possible
I am getting
constructors for
confused. Let me
that.
put an example here. V, and then we're gonna do left, Y, return Y, and then right, I don't know, X, or this in this case, you're gonna do, I don't know, 1, right? So your question is, can you repeat now with this example?
Yeah. So when you parse left, let's suppose you get the algebraic of the either, okay?
Yeah.
So that's what the parser will give to us. And later we will type check that node, and then we need to know, right? Oh, which constructor was that? Like, was that the left? How do we know? Because the algebraic doesn't indicate what constructor it was. It
No,
only
it does.
indicates,
No, it does. This is the left,
oh,
right? This text is left.
no, but it's a list of constructors, so it has all the
Yeah,
constructors.
we're gonna have to search it.
No, but okay. So, okay, now you got left and right, and they are both the same thing, you agree?
Yeah,
It gives the same T algebraic. How
yeah.
do I know if they are left and right, or left or right and right?
How do I know if they are left and left, left and right?
Because we need that for knowing completeness, right?
No, you mean exhaustiveness?
Yes.
Oh, that's a totally different conversation, my dude.
Well, that's pattern matching, dude.
No, that's part of pattern matching. Part of the pattern matching here is because as soon as you
Well, if
create
your
an ADT, you cannot
representation,
get out the values. That's the main purpose of having a first iteration, is to be able to get the values out of them right now.
man, no, like, it's pretty much useless if you don't have exhaustness.
No, I totally disagree with that. That doesn't make sense to me. Margareta, are you
Yeah,
there?
Sorry, what?
Do you agree that one of the main purposes of pattern matching is getting values out of the ADTs?
yeah, of
Well,
course.
yeah.
There is no way to
Okay,
disagree with that.
so there is a reason to do in this way, Nathan. Definitely.
Yeah, that is not. So if your representation,
I love how everybody here is like passive aggressive.
No, no, no. I am as Nathan said that. Oh, we need exhaustiveness, and I said no, we
I
don't
don't, I
need for
don't, I
first
don't
iteration.
see that so much, Mageta, but okay.
No, the reason is
But
that Nathan said something that I disagree. That's it, which is
okay,
okay.
uh, okay. So the first thing is, as we saw, that representation completely like disallow us to do the exhaustiveness check, right?
Yeah.
Like that's bad, even if you don't want in the first implementation, which I would argue maybe that's cutting down too much.
Okay, that's fair.
Uh, the other thing is, let's see if that is allow us somehow to even do only the extraction part, right? For example, in the evaluation,
I have a question. I have a question.
okay.
Let's suppose that you save the name of the ADT here. If you
But
do,
then that doesn't make sense
wait,
for the rest of the.
wait. Do you agree that if we have the either here, we could discover in the prelude all the either constructors?
Oh, wait, can you repeat again?
Yes. Because we are doing, and this is kind of a hack thinking about it, but that's gonna work. So because in the prelude we are saving left, right, but we are also saving either
Which
dot left,
prelude do you mean, like the context?
yes,
Okay.
and we are also saving the versions with the qualified names. If the algebraic is saving which type is this, then we could
Okay.
search in the environment and do and check. Oh, we have left, and we have right, and let's suppose that we have, I don't know, either middle.
Mhm.
Then it would throw a warning or an error saying of oh, not all branches are being pattern matched or something.
Yeah, I agree. If you save the constructor on the T algebraic there, we would be able to know it's branched to us because it will be there on the text,
Yeah,
right?
but I have no
But
idea how the parser will know this.
what's the problem with that? Well, first of all, disconsidering that part of how do you get the type, how do you get the right type, disconsidering this, if it's considering this, we still have another what I consider a huge problem, Amos. Dude, That doesn't make sense for all the other contexts in which the algebraic is used, dude.
Oh, you mean that this is exclusive to pattern matching, right?
Yeah, like doesn't make sense. The type describing a sum type has a field describing like one constructor. So you have like all of them somewhere. Like it it doesn't make sense for anything else.
Well, it makes sense for the printing having this name here because right now
Also,
our printing one is not showing like either, it's showing like left and right, which is bad.
uh, wait, can you repeat that?
Yes. So right now, one of the reasons that I would add this text right here to the TSG break to be carrying it is because I want to have better error messages or have better printing. Because if you go to the repo,
I give up on the error messages already.
if you go to the repo and ask the type of a left, it will not say that it is an either.
Dude, that's totally unrelated. That's totally unrelated,
No,
Linus.
that's I'm not saying it's related. I'm saying that is another reason to have this text here. That's what I'm
No,
saying.
no, having the text there would not help you with that.
No, it would. Definitely would. I can even show you where.
No, 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 because they are two different things. That's the thing that I was talking, the thing that would help you, right, with that printing is the thing I was talking about nominal. If only makes sense to have some types with names, then maybe should we put on the notes, that would be it. But in the case that you are proposing, that doesn't have the name of the type there that is being like placed to. It has the name of a constructor. It has left inside that text. It doesn't have either inside.
What? No, man. I'm talking about. Can you see my screen? I'm talking about this text.
Yes, this would have left there.
This would have left.
That's
Did
the
you
construct.
did you understand
Yes,
my explanation before?
Wait, what is
yes,
the
that's the
discussion?
way
Let
you.
me let me
Okay.
think.
Okay. Wait. What did you say, Magetta?
What is the discussion?
Let me explain
No.
the problem to Magita, and then you can confirm if I'm.
Okay.
Okay.
Okay. Go. Nothing.
Okay, so take a look on the following problem, Magita. Uh, Lemos want to parse the left and the right, and
Yeah.
from this getting a type, right?
Yeah.
A
He's
type
talking
for
about this.
each side, you mean?
Yeah, a type for putting there on Lemos is highlighted.
Oh, I see. The left and the right, you mean the literal left and right.
Yeah. The
Yeah, on
literal.
line 7,
Yeah.
yeah, those
Okay.
lines.
Mhm.
So he wants to parse that and get the type. The first thing is that type, he's always expecting to be the TLG break, right? It's the only one that makes sense.
Yes.
That's not really a type, right?
No, no, let's not go with this because that's the premise, right?
Okay. Okay.
Okay. That's fair.
Uh, mm. So the thing is, let's suppose somehow, and again, that will not be in discussion here, how the parser knows that, or how does he know the proper type to put there? Like, he just gets the proper type, okay? Uh,
Okay.
And then when parsing that left and when parsing that right, he will return the algebraic that is the either, right? The
Yeah.
correct one.
Yeah, that is the type.
Then it follows the question. Uh, I will have on the V there, right? I will have which label it has, right? I will know which constructor it's using, right?
Yeah.
But the thing is, when I'm evaluating, I will search to the branches, see which constructor that matches the V, right? The V constructor. But how do
Yeah.
I know? Because the type that the parser gave me lists all the constructor in all left, right, and all the branches. So how do I know which one was left originally? I
Can't you
don't.
do a search? Because that will. Let me
It
think.
will always be
Yes.
there.
The left would be a variable, right?
The left would be a variable.
Yeah. For example, like the question is, how do I know what is V in the evaluation?
No, no,
Although
no, no,
I
no, it's not.
okay.
You know what V is. You on during
Yeah.
evaluation, you know that V is a
Is there?
value that has a text for the constructor, right?
Okay. Wait. What is V? Can I
Okay,
know
put
that
the
it
value.
is a
Yes, you
left or
can.
right? I can. It's a
Yeah, on V
E
you
algebraic.
know. Well, you need that. Go
Yeah.
on values then.
It would be a E algebraic, right?
No, no, it's a value, right?
Oh, sorry. Yes.
To be this.
Yes, which is the same thing. Yeah.
Yeah,
Mhm.
yeah, kinda. But you see the label there, right?
Yeah.
on the V algebraic, that
Oh,
would
sorry,
tell us
this.
if the, yeah,
Mm-hmm.
so that would tell us if the V would, well, not be, but would evaluate to,
Left or right.
oh, yeah, exactly, exactly. So we know that, right?
Mm-hmm.
Now, what do we need to know? We need to know which of the branches matches this constructor, right?
Yes.
Yeah.
But we have no way to know because the type there that Lemos is returning from the left and from the right, all of them, it's the same type, the either type. And they list all the constructors. Which one is the left, which one is the right? We don't have that information.
I'm not getting your point, Nathan.
Okay, so you see the left there, right? Left Y.
Yes.
When parsing that, Lemos will return the line one up.
Yeah. So
One
this
up.
will be left, and this will be the type that left is like, I don't know, whatever is this type integer,
So
I
the
guess.
text is left, right?
Yes.
Yes, text is left. Text is
And
By
left.
the way,
type,
can you,
it's
just one thing. I don't think you can return T algebraic in that case.
no, no, no. We are not discussing that.
Okay, but go on.
But I think I
You-
can, by the way. I think we can, but go on.
I think you can because of the match, right? But anyway, go on.
Yes, exactly.
So the thing is, uh, sure. Then we have the left there as text, and then the list of types, and it's like the type for Y in this case, right? But that's one element of the list that T algebraic carries, right?
Yes.
The
One
other
element
would
of
be,
the list that is T algebraic.
yeah, you see that T algebraic has a list, right?
Yes. Which is the Y, Z, whatever it has
No, no,
inside.
no, no, no. The outer list.
Yeah, he's talking about this list here. Like,
It's a list of tuples.
Oh, okay, I see.
So this
Oh
has
wait, that don't. Oh man, I was misreading them. Okay, I see. Because this text would be the like Y, right? And then the type would be
no, 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 no,
no,
no,
y
no.
is not here, right?
Yeah, Y is not on the T algebraic.
Yeah, I'm gonna parse
oh
y
no, never
here.
mind. So the T algebraic
Oh,
is the
that's a
either.
different argument.
Oh man, okay, I
No, no,
see.
no, it's not.
So the T algebraic is the either, and then you have text left, and then type,
This
the
is
list of
empty.
the types that the left takes,
No, not an
right?
empty. Sorry,
Yes,
this is the type of y. Sorry. Yes.
Yes. Okay.
yes.
In this case, it will be a list of one thing.
No,
Yes.
no, no, no. A list of two. It
No,
has the right
the
element.
outer list is
No,
two. The inner
this
is
is
one.
for yeah,
Oh,
the
okay.
inside
Yes.
list to me. Yeah.
Okay. Go on,
Okay.
Nathan.
So you see, right? T algebraic has the outer list with two elements, left and right.
Mm-hmm.
Hmm.
So do you agree that left and right, like the branches of the pattern match, would return the same T algebraic?
Yeah. So if you have both, how do you know? Yes, I agree.
Exactly. How do you know what's left and what's right?
Yeah. So it needs to be another structure.
Yeah, but Lemos suggested a way to do it, right?
Yeah.
Now you can change the node limit.
then, then I suggested, okay, we can add text here,
But
and
dude, why do you need to parse a type there?
No, no, Ben, that's the premise. Like,
no, we don't.
don't.
We are discussing what is this node gonna be. That's the discussion.
No, but the premise of analyzing this possibility is it is a type, and then we are discussing. Well, I'm
Okay,
trying
but
to
why not change the premise to it is a text on the type?
because I'm trying to. Okay, that's a type, and I'm going to the point of okay, a type doesn't work. It is a text,
Okay.
but I'm working that case, right? So we can like understand.
Okay, so what I suggested with to Nathan was to add the either information here, because then we would know that, oh, these things
Yeah.
that are here, we need to we can like search in the environment and find, oh, do we have either dot whatever is this, and
Yeah,
so
but
on and
for
so
that,
forth.
it's better
Let
just to have a text and then you look up the same way, right?
Wait, Lemos. What you propose is to have the name either inside that text or the name left inside that.
That name
Yeah, the either.
either here.
What?
Yeah, that doesn't
The
help us
either
at
one
all.
wouldn't solve anything.
Yeah, no. Now I am trying to understand. Now I got it from what Mageta said. That Nathan, Nathan, you're talking about something different. I got the question wrong, I guess. Because your question is how you gonna
We
know?
assumed you meant that left would be there.
Yeah. How do you
Okay,
gonna know which T algebraic is this? That's what you said, right?
yes.
Yeah, you know it's an either, but you don't know if it's a left or right
It
either.
still doesn't help in anything, you see?
So you will need to add that name of it,
Wait,
like left.
I don't get the problem. We know that this is a algebraic. Why
What
do
is
we
the
need to
type?
care that this one is a specific algebraic?
During evaluation, we know that V is a left. So we go through the branches, checking which one is the same constructor as V, so we can execute the branch, the correct one.
So
To
far,
know that, we need to
no,
know
wait.
which branch.
Confirm, Linus. So far, so good.
No, I am understanding that we're gonna evaluate V, and we're gonna
Yeah.
discover that it is a left. That I got it.
Yes. Okay. And then
Then,
now, what's the next step? It is going for the branches and seeing which branch, what is the first branch that matches the V, right?
that
Yes,
is also left, right?
that is
Yes.
also left.
But
So
what are
you
the
see,
branches?
What are the branches?
Yes.
Left and right.
No, no. What is the
on
structure?
the,
The
yeah,
AST
the
structure.
ST that you had.
In the ST, well, that's what we are
Okay.
discussing. Yeah. And
No, no, that you
What do
had,
you
I
mean that is
mean, no, no, that
okay?
I had, I didn't mean like go back to the previous one. I mean the one that the parser will deliver you.
Yeah,
Like you can
literally
add the
right.
text
The
back there.
AST for right and AST for left.
I'm not getting the question. That's what we are
Literally
discussing.
right. Right. Literally start typing. Don't think. Start typing
No, no,
literally the
wait,
AST
let
for left.
me try to do it in a simpler way because, uh,
No, dude, like
That's the
he will
so,
see.
discussion. I'm not getting. Yeah, I'm not getting.
If he types, he will see. Just do
That
it,
type
man.
what? Type what? Go.
The
yeah,
AST,
you're not,
what the parser shows for like left. What is left? It isn't it a T algebraic? Is that not what you want to parse?
It
T
would
algebraic?
be left.
It's a tuple, right?
It is a tuple. And
Something like
then,
this, right?
yeah, so it's also going to have a right.
So this is what?
This is a
All of it.
algebraic.
Which is what?
A type.
The ST for what?
The ST for a type.
Left? Do you agree that this parsing this would be the same for left and right?
Yeah.
So how do you differentiate? How do you know which one is matching the V? Like what is it? I don't know. This is a neither. This is not a left or a right.
Wait. I don't
If
think
it
I got the
were,
question, but I got that this can't be a type. This needs to be a text.
this needs to be a text. Yes. Why? Because if it is a type, then it's like, well, it's the thing that has the left and right, not the actual text, which is what we want. So you need that to be specialized on the branch.
Yeah, I really don't think that's the reason in my mind that this needs to be a text. But okay, it needs to be a text,
Okay, you
regardless.
can try explaining after.
uh, so we evaluated the V, right?
Mm-hmm.
And we know it is a left,
Mm-hmm.
okay? So do you agree that we need to go through branch by branch, see
Mm-hmm.
which one is also the left?
Uh-huh.
But we have no way to know that since they will be all the same T algebraic.
We have no way of knowing that since they will all be in the same be the same algebraic.
Yeah,
Yes.
both right and left evaluate to the same thing. Would be parsed as the same way.
Would be parsed to the same way.
Both would be T algebraic, left, T, right, U. And then that's the left. And then right would be T algebraic, left, T, right, U. Those are the types of it, right?
Oh. Okay, that makes a lot more sense now, saying that way. So what we would do, we would parse them as the same.
Yeah, and I don't know how you would do. How you would do this on the
On
on
the
the
parser
parser
level, right?
because you would have to know that
It will
there
have to know.
things such as that a thing called left is
That's
part of a member of a type like the
that's why I
thing.
wanted the text to be here. Now you understand?
Yes, I do. But
Okay.
then Still cannot be an auto algebraic. You would have to have an environment in the parser to do it.
Yeah,
Like
you would have to have it
yeah,
to have the name there. You would have to have an environment in the parser. That's correct.
so that's just a text, and that's easier.
Yeah, and also in that case, the alias will not be needed because we can infer from the aliases. We
Mm-hmm.
can go to the env, taking a look which one is like on the right side. It's a sum time that matches. If it matches, we return the name on the left side.
Mhm.
But yeah, it's a text. So, okay, pattern matching. We have the expression to be matched, and we have the branches.
Yeah.
Each branch has, wait, what? A list of, okay, triples. A list of branches, and each branch has the constructor name, the binds, and the expression that is the branch, like the right side of the arrow, right?
Yeah.
So I guess that's it.
Okay.
We spends most of the time in AST.
No, but
Amazing.
that's discussion. That's important.
I love it.
Well, we could just say, oh, okay, I did this way, like I know that this way works, but that would not like
Yeah, that would not
have any
be.
learning, right?
Yeah.
Yes, the
Okay,
value
so
goes
type
away.
check expression. I'm assuming you're gonna have to have the env here
Let me think.
at some
Do we?
point.
I,
I have no idea. And e
I think yeah.
pattern
We need to look
matching.
the thing. Yes, makes
E
sense.
pattern matching. Just check
Makes
here.
sense.
Literal expression. It's there. Okay. So then we're gonna have. Uh,
Ouch! I just
where is
noticed a
it?
problem.
Okay, here.
This
So then
would
we're gonna
be a
have the.
runtime error, right? Wouldn't it? Or
What?
What do you
can we
mean?
capture this at a type level? Because imagine like this: you make more patterns than you actually can on the thing. Since it's just a text and we don't know how many it can take, then we would need to do this on evaluation or type
No,
check.
no, no, no. Type check knows that.
Does it?
This.
Oh, we have access to the thing. I agree. Mm, yeah, there's no
Oh,
way I think to. Well, there is to
wait,
put
Magenta.
access to the parser, but I
When
think
we type check the thing that is being matched, it will gives us some type that says how many is branch, what are the
okay.
name of the constructors,
Yeah.
what are uh, the types of the things to be bound. It says everything.
So we have how many things? We have the name.
Okay, so
Yeah,
this
okay.
list
The
is a list of
amount of things to be
triples.
bound and the types of it.
Okay, the amount you provided and the amount you are targeting. You should be targeting.
Mhm.
All right, makes sense. Okay, so what's the question, Linus?
No, I didn't ask a question, so uh, wow, this is actually in the data list. Okay. So the first thing that I want to do is to unzip these three things. Should we do that?
Let me see. What are the three things again? I don't
We
recall.
have a label. I don't know
Thank you,
why.
Emacs,
Yeah,
for
Emacs is throwing
just
me off.
a pure bullshit there.
Why would you
Pure
start by
just
unzipping? What is the logic of that?
Well, because we have things combined, I guess. And I don't know if we
define
want
it.
that.
Yeah, okay. List. It is a label, a triplet of okay. So the name, right?
Yeah,
Then
we have the
the
name.
variables they're passing to bind the
Yeah.
patterns, I guess, and the right branch, right? The
Yeah, so we have three
expression.
questions. Or we unzip them and then we do manipulations with them separately and then we combine them together back in. Or we make a function that handles three out of all of three at the same
I
time.
I think it's worth making a function that picks a triplet and does the magic.
Why
Okay.
not the following? First, we see what is the kind of manipulation that we need to do, and then we see if it's like more fitful to unzip or not.
Yeah.
Okay. So in my mind, I don't know about you guys' mind, but the only thing that we need to do in regards to the list of labels in the middle is to just to check the length.
Yeah, okay, that's a good check.
Okay.
Yeah. So the first thing you can call this branches or something because list doesn't make like really.
First, I think you need to get the type right of by the text,
Yeah,
the variable.
the label stuff, and we need to do a lookup, I guess. Is that
No,
correct?
Yeah,
wait, wait.
on the first, right?
Yeah, on the first
No.
label, I mean.
So you are forgetting about the most important thing, the to match. If it is not a sum type, you can quit already.
Oh, that's true, right?
Okay.
So, okay, so the first thing you have to do is type check the to match. So, potential sum type. So it's going to be type check expression using to match and the env. And the order is backwards. Is this okay? Then we do a case of that.
Yeah, we need to reduce it, right?
Yeah. So this needs to be what? T algebraic.
Wait, Lemus, we need to reduce it first.
We need to reduce
To
it.
compare, right?
Yeah, we're gonna do a comparison.
We need to do something. Wait, I think we need to do something else, right? Don't wait.
Wait, what do we need to do with the v in the match? So match v. We need to pick that expression. We need to type check that. We need to reduce that.
Yeah.
And
My
see if
question
it's an
is,
algebraic.
Let's see if it's
yes.
algebraic.
My
And
question
then we
is,
already know the magic. It
do we
is
need to
inside.
do something else? Like, weren't we adding like one of those days something else, like in a bunch of functions?
Wait, what, Nathan?
Uh, like, weren't we like the other day adding a bunch of check-ins on a bunch of functions? Like, I guess Lemus was doing that.
A bunch of
Do you remember?
No,
Yeah.
we have three functions that usually we interact with. No, four. Type checking, like we are doing type checking, we call type checking again. The reduction, kind checking, and more recently find placeholder alias.
Okay, okay. So do we need that? We don't, right? That's only for types on the nodes, right?
Yes.
Oh, then we are done here.
Yeah. So the T algebraic, we expect to have what is the name? A sum type, right? And I screw my Emacs screw things. It's this. So I already forgot. So a sum type in our case,
It's the theory break itself, man.
no, it is, but there's a condition in there.
Huh?
We need to check if the
Also,
seconds are empty, right?
no.
No.
No, 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 okay. So you know the Haskell way, like this data type that we are declaring,
Hmm.
it is a sum type and also a product type, right?
No, in Haskell, yes, but I'm talking
But
about
it's always
ours.
a sum type.
Oh, you mean the definition that we talked about before? Yes. But we need to see if this list is empty, correct?
No, no, we don't.
Wait, what?
Again, we want a sum type, right?
Okay, so that's it.
So knowing that the algebraic is the type, we already know that is a sum type.
Some types. And then other is going to be an error. Through error. And it's going to be type error. Expected some type, but got. Okay. Okay, so we have the sum type. So what else? We already checked that the to match is indeed a sum type. So now we need to check. Now it is the part that I don't know how we're going to do. In my mind, we
Yeah.
need to do a lookup of this label here.
Well, look up where.
In environment.
No.
No. Okay.
What environment would you be looking for?
Which
For what
environment?
reason?
Wait, we don't? No, we need to pick the type of the match of the clause we're adding there, don't we?
Well, on the sum types, not on the.
Yes, the sometimes. That's what Lemus is
No,
saying.
no, no, no. No, I was not saying that. I was saying this guy. But you are correct. Actually, we need to do in the sum types in
So
here.
let's do a list, like in commentary, to know like all the checks that we need to do, and then we decide like in which order and how to implement. Right?
Okay, so first is to type check the to match expression to verify that it is indeed a sum type. Then we need to do a lookup in the
No,
um,
like because that doesn't say specific what we are checking for, like a lookup to check what, right? So one of the things you want to check is if the list of constructors on the branches is the same list of constructors of some types, right?
as the sum types one.
The list of constructors of the branches, right?
Um,
Yeah, so you see that already includes the names of the constructors and the length,
the name and the length, yes.
right? And then, well, you can do like at the same time, I guess. But the other thing, and I don't know how to write that well, would be checking the binds, right?
What do I need to check
Regarding,
in the binds?
for example, if I have left y, then I need to check, does the constructor left in the sum types has the same amount of types here and such?
No, but that's checking the length.
Uh, yeah, I guess it's only checking the length, right?
Yeah.
Yeah, so we need to check that. How do you write that?
Okay, so no, but I think that this second bullet point is already enclosed
Oh
here.
no, it is not.
It is not. Then I don't
Well,
understand what you said before.
not as we wrote. This is to get all the constructors of the branches, so left, right, and then checking all the constructors of some types, that is left and right. But it doesn't say anything about the types that some types carries, about the binds that the branches have it.
Wait. Then I'm confused again. Do you agree that the algebraic carries out all this information?
Which information?
Left, and then it has like a list with only one.
Yes,
Okay, so we already have that info, right?
yes,
And we already have the info that the user provided by this list here.
yes.
Yeah, so we when we check if this actually pattern is equal to this equality quote unquote that I'm calling here, that's why I added this parenthesis. This will verify if the name is equal and the length is equal.
Uh, no, take a look on the representation of them.
Fuck. The algebraic, then we're gonna have a list of left.
No,
Uh,
wipe it off the ST, right? That's easier.
no, but the STA already said. We already said that, oh, it has a left and a list of things that it's gonna carry, but we're
But
still not
now,
agreeing, so I'm
like,
gonna type
put
it
the
here.
yeah. So put the representation of a branch.
Okay, so right, and this is gonna be U. Okay, so representation of a branch is gonna be match V, left Y.
Yeah, that's not the representation of a branch. That's like the syntax for pattern matching,
Oh,
right?
you mean the node already parsed?
Yeah.
Okay, so E pattern matching. This is gonna be V. This label here, the first one is gonna be left. This one's gonna be Y, and this one's gonna be the branch that I'm saying that it's one, right? So as you can
So
see, it's very easy, right? So you just check if, oh, does this, oh, this. Okay, so what's the length of this list? Oh, it's one. What is the length of this? Is one, so we're good.
yeah. So again, of course, you have the information to do all those checks, but that's not what we are saying on that comment. Regarding equality, what I was saying is you get all the constructors from the algebraic, that's a
Mm-hmm.
list containing left and right,
Mm-hmm.
and then you get all the constructors from the pattern matching, that's left and right. It's literally sorting and comparing the equality of a list. That's equality. what you have there, like it's a more complex checking, but of course we have the information.
Yeah. So I still agree with what I said. So this for me is already saying everything that you
I
said. But
still
okay.
agree with myself.
Yeah, I don't understand why
Okay,
this is not
so
writing saying that. But okay.
okay, but let's go. Uh, Something else that we need to check. That one is a bit more worse because we need to do the following. For every branch, we have to attribute the yeah. So for every branch, we will prepare a new environment, putting the binds there with the proper types, and then type checking the expression on the right side. After doing for all the branches, we need to check if all of them are equal.
Okay, but that's the second part. I want to focus first in the first part.
Well, but why don't you comment that last check?
Oh, that's fair. That's fair. So, um,
Check if the
have
branches have the same type.
check if the branches have the
Like
same type.
adding the proper binds with its types right on the context.
Yeah. So this this will transform this list to this. This name, and then we're gonna pick what is the name binds, and then we're gonna have nothing, and then I'm just gonna return this. So name and binds and list. Okay, and then now we compare them. Some types of. This don't need to be a case. So if they are equal, then we need to do the thing that you said there. We need to check if the branches have the same type. But else, that's an error. Yeah, but doing it this way, we lose granularity to throw a good enough error message.
Who cares, man? We don't have good error messages for a long time already. It's not now that we're gonna fix it.
Okay. Um, constructor name or I don't know how many binds are wrong. Expected this and got that. That's gonna be show some types and show list prime. Okay, so it is saying that we have a problem with the type in here, so let me check. Oh, this is also wrong. Okay. Okay. Now we need to do the final third bullet point, right, Nathan?
You know what's funny?
What?
That would pass in Python.
That's okay. Nathan, you there? Oh, be right back. Okay. So the last thing that you need to do, right, is to type check all the branches. Is to type check all the branches, and you need to see if they have the same equal type, right? Whatever it is. So let's do a let here. Branches types. That's gonna be equal to. Oh, actually, this is not a let. This is branches types. Type check expression env. That's going to be a 4 actually. A 4 of. Oh man, we need the branches, right? And I am already like undoing it here. That's kind of sad. Okay, so let's pick branches. Unzip all of that. Okay, so this is a list, right? Oh, what is this? It's a list of expressions. Great. So the 4, we'll pick the branches. I can see the type because of Emacs. How we are doing the list? The list will be the one that we want. Okay, fmap reduce. We are also missing that. So then we're gonna do list all. Well, this can't be an empty list, right? As far as I can tell. Well, the type system will not tell me that.
Mm,
It's not gonna be. Yeah, it's not gonna be. So this is gonna be another if. So it's gonna be
actually, let me think. These branches
come from the parser.
yeah, but that doesn't mean much, right? That it comes from where? It comes from the unzip of the.
No, this is all the branches that we have for the pattern matching. So we have like left and right. We have 2 branches. So this is a list of 2.
Oh yeah, so yeah, there should be a parser error.
Yeah. So we're gonna pick that, and we're gonna see if they are all the same. Branches types. If they are the same, we're gonna do what? So the return of all the pattern matching is gonna be that, right? So let single type. Well, let's call this type this. Head branches types. So then we can exclude all of that. So it's gonna be type this. It's gonna be branches types. Type that. And then else is gonna be throw an error with this. Saying all branches in pattern matching should be the same, but
Branches in the pattern match diverge. Something like this. Make it more
that's
professional.
types in pattern in branches of pattern matching.
Branch types diverge. Even smaller.
Branch even smaller. Branch types diverge. And then I'm just gonna show all the types.
Then remove the dot, right?
What?
Okay, you're gonna show all of them.
Yeah.
Okay, it's a terrible message, but that's fine.
I get the style. Okay. Is that it?
Let me read. I wasn't paying full attention, if any at all. So you reduce the type, then you see if it's algebraic, then you get the sum types, then the sum types prime is mapping the second. Okay, you're getting the length out of the second fig
Yeah, because the
to
second
see if
has
they
like the
match.
left, it has the T and the U, you know?
Yeah, okay.
Okay.
So and then you unzip, and then okay, you map the name, the binds, and the branch to Name length of the binds. Okay, and the branch. What is the list? Okay, it's coming from the other thing up there.
Yeah.
Right, I see. And then you unzip, and then you have the branches and the list. Then you have you compare if the some types. Oh, okay, I see. So if the length is different, right? If they're like the
And the
content
names,
and the
the
length is
length and
different,
the same, and the name.
yeah, then you do branches types. Blah, blah,
Then
blah.
we pattern match the branches of all the patterns.
Yeah. If they are all equals to the same type, then
Then I return
okay.
that one.
Yeah, okay. This is fine.
Yeah, this
Okay, now
seems
let's do
totally
the
fine.
evaluation.
Yeah, that's the evaluation. Oh wait, no, there is a gotcha. Removing this, I remember. So Nathan said that we need to add things to the environment, which is true.
Uh, Adding things to the environment.
Yeah, because the binds that we had, right? The binds that we had, they need to be added to the environment as variables. Do you agree? Like the
Mhm.
left y that you made, you need to put the y in the environment for the branch on
Oh,
the
yes,
right.
for the expression, yes, that's true.
Yeah. Hmm. Okay, so how the heck are you gonna do that?
Hmm. Vamos.
What?
Um,
Okay, I have an
uh,
idea.
when you are comparing the constructor stuff, you have to sort them.
Why?
Why sort?
Wow,
Oh, with the branches, right?
because
No, if
because
you
the
don't get
user
it.
can type in any order, right? The
But that's just to compare with the branches, isn't it?
what I'm saying is, when you have
Oh, this
constructors
isn't a
on
set.
both
This is a
sides,
map. Yeah, the order matters. Yeah, he's right.
wait, that what? They are lists, right?
Yeah, they are lists, so the order matters.
Yes.
Did you get the problem, Agatha?
Yeah. Mhm.
Well, you could transform them to sets, and then it's done.
Well, yeah.
Actually, that's a problem, dude. That would like remove the duplicates. What could induce to an error?
But
The
can you
duplicates you
have
want.
a duplicate? Oh, but wait, you're saying that you can have two branches doing the same thing, right?
Not doing the same thing, but having the same constructor name in the set would hide that error.
But that's not an error, is it?
Of course it is. A
In F
case that
sharp,
would
it's
never
true.
happen.
Wait, I don't get it. So the problem with transforming them to sets is gonna remove duplicates. That's what you said?
Yes.
What's the problem?
The problem is that you're removing duplicates. If the user puts two lefts, that should be an error because the second left one will never be reached.
Let's see if that's an error in F sharp.
Oh, if you have two lefts and both of them are not like pattern matching the value or the literal, you mean?
No, if both are lefts, dot.
Okay, Magetta, you can check that.
If both are left,
Yeah, it will give you a warning of a case that will never happen.
let's see. Dun, 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 dun. Uh, Wait, a warning is not an error, right? You
A
said
warning
it
is
would
not
Yeah,
an
be an
error.
error.
A warning is not an error. That's
Yeah,
okay.
yeah,
yeah,
you
that's
said an
something else.
error. Like, that's different.
Well, we don't have one.
Okay, I think a warning F sharp does give you. For
Yeah.
incompleteness, but
Well, it's not incompleteness, it's the opposite.
here.
It's too much complete.
Warning. Incomplete pattern matches on this expression.
No, no,
Okay,
no, no.
I matched this one and like just literally this one and then I pattern matched one equals print one and then one again print two. And then it
Hey,
complained because the type is not being A
Can you
fully
give me
matched.
a print? Because I think that's not what we're talking about, Magita.
I don't know what you're talking about then.
Give me the print.
Where's the Wimpy chat?
In the chat.
Yeah, I don't see any.
Uh, yeah, that's not what we're talking about. What's your... Oh, wait.
It is. It is two patterns with the same thing.
Wait. Yeah, but that's tricky, right? Because there are two problems there.
Oh, ignore the other. Like that's. I know the other is
No, no, no,
ignored.
no. It's not we ignoring, it's the compiler ignoring. He will not. So do something like, what is the result?
What do you mean the
Zero
compiler
and
ignoring, man? Did you get
yeah,
what I was saying?
you will understand, yes.
No,
So
I
do
know the compiler ignores the other because it just gets the first.
no, what I'm
It's the
saying
same
is,
case of making a general case on the first pattern and then doing something more restrict afterwards. It will ignore the other.
yeah, but the thing is, you have two errors on that thing. So not necessarily he will give the one that we are talking about, right? Because in that case you have
Okay, so let
incompleteness.
me do an option then.
Yeah, so match the none two times and the
Yeah, in
sum
chat will be
once.
the same thing. None, none.
And also match the sum as the last one.
It does give a warning that it will never be matched.
Yeah, it's not incompleteness, right?
Yes, not completeness.
Yeah, so there it
So
is.
it is exclusive with the other warning. That's strange. Oh no, dude, it was showing there. Like you see,
What?
look at the message there. Like
Not
there are two
comment.
warnings.
Oh yeah, yeah, that's
Yeah,
true.
it grouped. I just
Oh
didn't see.
yeah, it gives off. Let's see. That's nice because they have like the number for the warning. They are even like sequential.
Man, I just dived in a hellhole today. I discovered how SQL Server handles the errors. And it is literally like, you know, the limit of integers? It is like 2 to power 31 minus 1, right? That's the max integer of like signed integers. And then
Well,
like I
it
saw that.
doesn't say much. It doesn't say like how
No,
many
no,
bits you have.
it does say when you see that they have literally a table, a virtual table on the system.
No, no, what I mean is only say ints doesn't tell you anything. It doesn't say if you're using 64, 63.
That's why I say it's a normal integer, so you can assume it's like a 32 that goes for like minus 2 to the power 231, 2, 2 to the power 31 minus 1 for you having the signed integer and 0. So there is literally a table there because the default integer I think is 32, right? But anyway, they have a table literally mapping all the error messages, which is literally Greg level, man. It is like, okay, the same error message now written in Spanish, the same error message in Hungarian, the same error message in Chinese, and so on. That's literally this. Like, and then like you see the rules, like there's totally like out of nowhere. Like for example, uh, messages for like codes reserved for error messages, they range from 50,001 to until the end of the integer boundary. So they have another dude.
They are very, I don't know the word in English, but precavido, right?
Dude, what the heck, man? I was looking at this.
They
It's
sure
you
have
have
room
literally
for the
2
next
billion.
1,000 years.
Man, you literally have 2 billion rows to fill with like messages.
Oh yeah,
Dude, what the
I
heck?
guess they can spare to be very specific in the yours.
I know that I was reading that and I was thinking that's literally code from the 90s that nobody ever touched. They just touched to add things new there, but they didn't modify anything because it would probably break. By the way, I'll start my database today, Nata. I already know how to.
That's nice.
I will not. I will just not make it in Como Lisp because that's insanity. Lemos is a human compiler.
Why do you say that?
It doesn't read their messages, man. He knows what they are. He
He
has all the
feels,
types.
right?
He has loaded all the types of this every variable there in his head right now. Oh, this is a swap.
This is a what?
This is a swap. You unloaded that, so you need to load it again for the memory. That's why
Oh,
you were
take care with
breaking.
that, Lemos. Context switching is expensive, man. You can talk in private.
Yeah, it is. It is kind of
I
complicated. Yeah.
can.
Okay.
Yeah. I can remove the parentheses, I guess,
Yeah, I don't know
from the out.
what is that is suggesting, by the way, but well.
Mining for types.
Shadows in the morning.
Shadowing.
Dude, this shadowing warning, man. Why? TS. TypeScript?
TypeScript. So what was you suggesting?
Just remove the parentheses so the H list. I think it's parentheses, right?
Emacs is giving me a hard
Oh, but
time.
didn't you add more lines to this crap?
No, I didn't. Okay, it was because of use
Okay.
of the prefix fmap. Okay, let's read this now again. Ah.
I don't want to.
That's a lot to read.
Okay, so I just all of this because we need to add the variables. But okay. Let's go. So the first thing that I do is to pick the types that we parsed the to matched, right? So and you got an algebraic, then you got a list of text and a list of types. Okay. From that, I am picking that and getting two other lists, right? So I'm getting the
Wait,
list.
you are mapping first, right?
No, I am like summarizing what all this is doing. So the
Length.
first thing that I do is to create the same list, but having the name and the length of the second list, because this is a list of name and a list of types, and then we want to have a list of name and length in here. So this is this guy. And then because we're going to potentially use later, right? I'm also saving separately the types of the binds that they need to be in the future. That's okay. From the list of the e-pattern matching, I am, which is down here, I'm creating other two lists. The first one is to have a list of tuples in which the first is the label and the second is the number, because we want to compare with this guy, with this other guy here, to see if they are equal both in name and the length, right? And I'm grabbing the branches and the binds and I'm saving them because we're also going to use them later. And because of laziness, that's not a problem. Then what we need to do is, if we are equal in this list here of having the number, the name and the length being the same, then I am zipping the branches and the binds with the types that I got from here. So this now is a list of two tuples, one inside the other. Are you there, Magit?
Mm-hmm.
Okay. So this is the branch. These are the binds, and these are the types of the binds. Then I am grabbing that and type check, and we're gonna type check each one of these branches. And how are we gonna do that? For each branch, we're gonna pick the environment, and that's an important thing. The environment for each branch needs to start being the same, right? So you don't share environments between branches. It's important. So you pick the environment, you pick the types and the binds, and you're gonna update the environment with this function that I made here. Actually should be add variables. Add variables to the environment that picks a list of of names of variables, their types, an initial environment, and the updated environment. And we just do a fold to do that. And then we pick that new environment, we type check the branch, and we reduce it, and then we do the same thing that we were doing before. Okay, Magit?
Mm-hmm.
So, okay. So this should be just fine.
I think the evaluation is actually easier.
Yeah, I hope so. So let's go to the typer. Let's grab this. Let's go to the evaluator. So where do we do? Yeah, we do it in here. Okay, so what do we do to evolve this stuff? Go on, Magit. How much
Wait,
time we are here?
I was reading a message from Jay-Z saying, "Man, I just realized Scrum is a poor replacement for hiring smart people." That was,
That's a hot take. We are
yeah,
live,
that
by
was
the
a hot
way.
take. Anyway, that doesn't matter. It's a discussion.
Yeah.
Uh, and I don't have any guarantees to share this opinion. But anyway, so let's see.
What should we do to evaluate eval expression?
Let me think. We need to just see which one it is and then just evaluate the right. I think it's simpler. So
Wait. The first thing is to grab the evaluated value, right? The evaluated
yeah,
to match.
yes.
Match.
So
So it's
yeah,
gonna be just eval expression,
to
env
match.
to match. Then you do a
Okay.
case. This needs to be going to an v
Is this
algebraic.
yes,
There's a
okay.
label here and
Uh,
there's a list here.
are we just handling VLGB? Okay, we're ignoring like literals for now, right?
Yes.
All right. So
And then everything else, at least for now, we're gonna throw an error
mhm.
saying that error expected the algebraic value but got this.
On the
Okay.
list there, what is that list that
This
the pattern
list
matching
is the
has?
list of the name, the binds, and the expression,
The
which is the
name,
branch itself.
the branch.
Yeah.
So
So in my opinion, we
we
can
just try
drop the
find.
first. The drop does the first one like which is
Wait,
left and right that doesn't matter.
it does. That's the thing that you're gonna match.
No, that. Oh wait, you're correct.
You're gonna
You are
match
correct.
that and the labels as well.
Okay,
And then
so
you pick the
for
labels, find in the environment. No, sorry. Pick the labels and add to the environment with the things of the match, right?
okay, so
Like,
one sec. So we're gonna have
yeah.
two, I don't know, labels. We're gonna have binds, and we're gonna have branches here. This is gonna be unzip 3. And there are two lists in here, by the way. So one should gonna have to be prime, I guess. So let this. Then I need to do a find. Find label in labels, not in labels. Labels. So if we have a nothing, that's an error. That's definitely an error. Nathan wants to do it in a fold. That's interesting. Nathan
Everything
wants
is a
to
fold
do in
actually.
a fold. He wants to do it in a fold.
Um,
Can we do this in a fold? Because if you don't find the label at the end, how are we gonna know?
I think it's just trolling, man. I know. I think we can do this in a fold, but I don't think it would be wise doing it.
Okay. Okay, so didn't find label this in the list of labels that. So we didn't find the label in labels. But if we do find it, right? If we do find it, what this function gives me, I already forgot. Find. It gives me a maybe a and returns the thing. Oh, it gives me the first occurrence. So we don't care about that, I guess.
This chat is literally every chat Benevides like is in, it becomes a swamp, like literally.
Okay, now it comes the thing.
Okay, if you find something, then you need to add again. I'll repeat. You need to add to the labels you are adding, like of the that you found on the algebraic. So it's I think it's the list,
Wait, it's
right?
not. It is actually not smart to unzip this. You know why?
Mm.
Because we're gonna have to zip them again and stuff like that, and be like, oh, this is the second, so I need to pick the second branch in the second group of
Yeah. Okay.
bindings.
Mm.
So what we're gonna do is the following. We're gonna have label this.
Not the unzip set.
We have binds and we have the branch, and we're just gonna see if the label this is equal to the label that.
Okay.
Yes. This will return for us all the thing. So we're gonna have the
Mhm.
binds back, we're gonna have the branch back.
Yeah. So let's
Which
see.
means that we can
So
just do like
let's recap.
this.
We need to get the things inside the list prime, which are the labels the user bound to the thing,
We need to add
right?
the we need to add the binds to the eval environment and call evaluation on the branch.
Yeah, the binds to what? To the things that you have inside the evaluated match. Wait.
Wait, how,
Oh no,
wait.
wait. The wait, which is the branch? I'm confused. It is the list, right?
No, no, no. Wait, I think you
Because
are
we have two
confused.
things: the list and the things that are
Oh, we have
matched.
this list here.
Yeah, so these are the values, if I'm
Oh,
not
we need to do
mistaken.
we
Yes.
need to do a check here.
Check on what?
If the length of the binds is not the same. Well, the type checker should do this.
Yes, this is the role of the type checker. Yeah.
Okay, so the type checker will check the length. That's okay. So we need to bind them together, right? Zip them together.
Yeah,
That's
so
what you're
it
saying?
is the opposite of what I'm saying. It is in the list, bind as the labels, right? Can you check the list? Which one it is?
No, wait. Ah,
I
we
think it's the binds you
we
have
want
there.
the binds and the list prime. That's
Yes.
what we want.
Okay.
So this is gonna be a let. So named no binds and values. We're gonna zip them.
This could be a fold.
No, this will be a fold, but I'm making it the dumb way first. Then we're gonna copy paste the function that I made here, like that. I'm gonna do like that. Actually, because this function is not asking for it, I'm not gonna bind them. What the heck happened there? Let. Okay. So you're gonna have the vars, you're gonna have the environment. So it's just gonna be a map. It's just gonna be the fold in this case. So you zip them. This guy is E. Map insert instead of a type. This is gonna be a value.
Mm-hmm. Hmm.
These are values. Right. So this is the function that you're gonna use. Then we're gonna do a evaluated. Actually, no, we just call the thing itself. So for eval expression, this guy will be add variables. Then you're gonna do binds, list this, and the current environment, which is this, and you're gonna pass the branch. Variables env. Okay. So this should be it. Oh, we don't have the labels anymore here. Didn't find labels. The list of labels. Okay. Is that it?
I think so.
Yeah,
Just
so you
binding
just
and then
fold,
on the branch. Yeah.
map insert. Cool.
Just run it. Write the
No,
parser
now we
and
need to
run.
parse it. So let me think about that. So that's an expression. So let's think.
So did you see the syntax? Just don't forget to add another thing to be consistent.
Okay, the syntax that I'm looking for is match v left y
You're
something,
forgetting one thing.
which
Oh man,
is
that's cringe. That's a cringe syntax, Lemus. What are you doing, man?
I don't know why you're calling cringe, but okay, go on.
That's what Nathan was like marveled about.
No,
Anyway, I
the
will have dinner. I'll be back.
the hell of parentheses. That's what you want.
What do you mean hell of parentheses? That's consistency at its peak. Anyway, I'll be back.
Okay, that's not that bad. Like it's very bad, but it could be worse. Could be a lot, well, a lot worse. Okay, so parser t as the expression. Then let's go. So the first thing is open delimiter, then the string match, and then skip. Then I'm gonna have a to match here. So this is gonna be in XPR expression p skip, right? And now we're gonna have to have the branches. Okay, so let's do a parser for a branch first. So it's a between open delimiter, close delimiter, right? Yes. And actually, I think we're gonna need even more than these. Pattern, which is also a between open delimiter, close delimiter. So this is gonna be a variable generic. Skip, skip, and then we're gonna have a many here. Actually, this can be a many 0. Right? So this will be also skip variable generic skip. Right. And then a branch is a pattern surrounded by another expression p. Then we're gonna have the branches, which is gonna be many one skip branch skip. Hello, Nathan. Okay, this is gonna be pure e pattern matching be uh, oh man, how are we gonna do that? How are we gonna do that? Okay, so we can't do a tuple here. So this guy is now that. This guy is being set to be like that. Mm, wait a second. What am I matching again? So this is the first thing, and these are the second things. The second things are they are triplets. Triplets. Triplets, triplets, triplets. They are triplet of this left, this list, and this expression. So we can just call expression P, use this, and then we can nuke that. Then there's gonna be a branch. Yes. And then we're just gonna do pure E pattern matching to match branches. Ta-da! Okay. Uh, okay, ready, Nathan? Oh, we are missing at some point a closing bracket because I'm opening one here. So let's just do that. Close the limit. Skip. Okay. You're not ready. You should be ready, man. You're gonna get there. So let's create another example, call that a pattern match. Pattern match, we actually grab things from here. Whew! Let's go, let's go, let's go, let's go, let's go. So let's make a function get left. Well, it's this, get left, which is going to receive a value either. A value either has the type, this one specifically will have either string integer. It will return the string. And now it comes. So match either. Well, actually this is the time in which I'm gonna do that. Nope. Nathan is not ready. Nathan is not ready. They're matching. Why you're not ready, Nathan? You should be ready, man. It's gonna be okay. Why the heck the code is like that? Okay, so never mind. Okay. Okay, so match either left x. Let's say we're just gonna print stuff. So this is actually unit. So x So if you have a right y, it's gonna be print either. Print integer, but this is not gonna work actually because we need like that. It's gonna be like that. Let's set a space here, and that's it. That should be it, right, Nathan? Right? I don't know. uh, okay. So let's call the function print either, right? And let's pass a right one. Yeah, that's it. That should be it. Let's tackle the errors now. Woo. Uh, oh wait. Wait. Delimiter. I think there's a reason why I did it in the first way. Yeah, like that. So open close delimiter. So we're talking about this one. We're talking about that one. Then you're gonna have a variable generic, many of these. Yeah, we need extra delimiters. We need extra delimiters, dude. That's not gonna work. Crap. Yeah, because we have the internal ones. You see these ones? This is not an expression. And we are just parsing the left and the many things. We need to have extra brackets surrounding these ones. So that's why I made it in that way. That makes more sense. Uh, so between open delimiter, close delimiter, delimiter. We need extra stuff, Nathan. That's the reason. All these guys. I need to grab all of them, put it in here. Okay. How are we gonna do that without being a mess? That's a very good question. So uh, let's do it this way. You're gonna have an XPR. You're gonna have P and binds, and the return of this is gonna be P BS XPR. Yeah. So what is this returning? Text and text. Okay, that's correct actually. Now I need to see why this guy is not working. Why this guy is not working correctly? Da, 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 da.
Back. And it didn't work, did it?
Well, it worked. Like I'm pretty sure this thing compiles. Yeah. But the
Oh,
reason the problem is that I noticed that we are lacking brackets before I
mm,
tested. So we need one pair of brackets to surround the left and the many binds. right? And we need a
Hmm.
brackets to this to the pattern match and the branch, right?
Yeah, so
So
the one for the
this one
branch
is for
and
the
the one
branch,
for the, yeah.
and this one is for the left and the binds. But I'm having a typing problem here, which I don't know why. So this is a list, right? Yeah, this is a
Couldn't match the
list.
text, blah blah blah. Dude, I can't read this parser stuff, man.
Yeah, no, that's
Like these
okay.
errors
That's
are
okay.
terrible.
Yeah, this is where it starts to get nasty. So let me just think a little bit. Let me think.
So
So
no as everywhere.
no, not
Okay,
everywhere.
go.
Definitely not everywhere.
So let me read the code. So you first pick the match and you open a delimiter and you close there. So this is fine after you do the branches. And then the thing to match is the first clause, so it's just one expression. That's fine. And then you do pattern. It is a between an open and close delimiters. Fine. And then you send to a tuple. You pick a variable, which is the left, right? And you
Mhm.
pick another variable, another many variables possibly,
Yeah,
which are for the
X's and the Y and the
x
Z.
and y, whatever. And then the branch is open delimiter, close delimiter,
Yeah.
uh, and then okay, this is the outer parentheses, right?
Yes. This is.
And then you
uh,
should pick a pattern first, and then on the other thing an expression.
yeah.
So that's it. Why? What is the complication there?
Yeah, every single time that we try to use a between a let, I think I remember having this problem. Because this is not
Like,
returning to us the value, right? This is returning a parser.
yes, but
Then we are doing
what are
applicative
you
with
trying
it.
to do there? Isn't it just pattern? Yes, just this without the like. Oh, you're doing that to dismember and mount the things,
Yeah,
isn't
it
that
is
it?
because our type requires triplets, right?
I see.
You can never do like that with the applicative. Pattern needs to be a function, like enroll in the type.
Enrolling in a type.
Yeah, you cannot do only two stuff on the.
Oh, wait. This is wrong. I'm so fucking dumb. This is this, right? Yeah, I am dumb. Okay.
Okay, it was like you were trying already to see it is okay.
Yeah,
Makes
this is
sense.
not a tuple of two things. This is
Yeah,
applicative, so this is a function that receives two things. Yeah.
makes sense.
Okay. Okay, it should work just fine. Yeah.
If it
Now,
works, I'm gonna start doing the the standard library.
I don't know
Natan
if you
will help,
should,
right,
but
Natan?
okay.
Nope. Oh man, such hatred.
Did I type
Open
it
file
wrong?
does not exist.
Yes. Better match. Am I typing correct? Did I save that file?
Pattern?
Is this saved?
Maybe not. No,
It
you did.
is. Pattern dot. Oh, it is examples.
Okay. Bound variable match.
Ooh, that's
Oh,
a
ban
problem.
list.
Oh, a list. Yes.
We
So,
have to always remember adding this garbage.
so match. Show match is equal to this. Now we are talking.
Well, you forgot the
I forgot a space
skip, I
somewhere.
think, somewhere.
Yeah, I definitely forgot a skip. I
Um,
think it's in here. Skip.
pattern. Yeah, makes sense.
Uh,
On the end, don't you need one?
No, I don't think we
Mhm.
need because I'm already adding in here.
Uh-huh. Yeah. Awesome. Okay. It's
let's
right
let's
too, right?
let's fix is this correct? Yes, it is.
Yeah, nice. Oh man, this is so cool. Do a do a left now.
Okay, so this is a test.
Not on the chat. True. Awesome. Oh man, so cool.
It works.
Yeah, it only sucks that we have to do a print for this, right?
What do you mean we have to do a print?
Well, the type is like, uh, wait, you pass into the print. Okay, you're just printing inside, and then that's the name of the function. Never mind. I thought it was another thing. Like a print receiving an either,
Yeah,
and then you unpack it. Yeah.
I'm gonna finish the stream. We
Ah,
did it,
nice.
guys. Well, we didn't test any sort of corner cases,
Oh, it's
so
working. It's
forget
working.
about that.
It's working.